Hi, hello class. In our previous video we introduced integration, and I talked about the basic rule of integration, and let me just recap on that. But while I'm recapping on it, you can also see the video icon will pop up on your screen, and you can also check that out to watch the integration video if you've not done that. And but just for those who have already done that, just recapping on it, we have that when you are to integrate a particular x raised power of n being the power with respect to x, or dx if you might call it, then we get what x raised power of n plus 1 over n plus 1, then we add what our constants. Now today we'll be talking about integration of trigs, logs and exponents like we have on our board already. And in integrating trigs, logs and exponents, remember the principle of integration. Integration is actually the opposite of what? Differentiation. So it means that if I was to say that Ada is a boy in differentiation, then in integration the boy becomes who? Ada. You just take it conversely, right? So let's look at this here. So we have that when you differentiate sine x, you get what? Cos x. And therefore in integration, when you have to integrate cos x, what do you get? You get sine x. But remember, always put your constant k or c, depending on who are you writing it to. I know that most textbooks use k, and also some textbooks use c, like you can see here I use c in this one, but that is not really relevant. Just make sure that you always indicate a constant with whatever term is agreeable between you and your examiner. Okay, so you can go through all that we've done. We'll still take questions on this, so I don't want to just start reciting it together. But there's something I'll talk about, like exponential x. Look at the exponential x situation. We have that when you differentiate exponential x, you had what? Exponential x still, like it didn't change. And therefore when you integrate exponential x, we also have what? Exponential s plus k, like nothing changed. That's actually true if what you are integrating or differentiating is having a power of 1. Like in this situation, our exponential x has a power of 1, so we can say that exponential x, the power is like an invisible 1 multiplying x. So but what if we had like a power of 2 and we're trying to integrate this with respect to the x? What will happen? Then it will be what? Exponential 2x, and then you put your what? 2 under it plus k. So this is what happens every time. You always take your power and you put it down if it is if you are integrating. But if you are differentiating, so let's say for exponential x, I am finding you are differentiating exponential x with respect to the x, then to be what? It will be exponential x, sorry, for 2x, let's put it 2x, it will be exponential 2x, and then you put your 2 behind it. Remember, in differentiation it multiplies, in integration it divides. So this is just what I wanted to just point out before I begin to solve questions. So let's take a question and we'll look at it and let's see how to solve it. So let's start with something very easy, and in the next videos we'll take more questions to work on. Okay, so let's look at one here. So I have this one on in my book. We're asked to integrate with respect to s 1 over x plus cos x dx. Okay, so let's integrate this. Now remember, when you have a minus or a plus sign, you can just split it into 2, and that becomes 1 over x dx plus integral of what? Cos x dx. Okay, so what is integral of 1 over x dx? Remember, when we differentiate ln x, we get 1 over x. Therefore the converse or the opposite is also true, which is what? When we integrate 1 over x, we get what? Ln x. And remember, don't forget your constants. So we have what? Here will become what? Ln x. Now, but I won't put my constant until I'm done. Remember, I said that in the previous video. Do not put your constant until you're done until you've integrated everything in that line, in that equation. So don't say I put constant k here and then I'll now integrate this one and also put constant k. That would be very wrong. So please don't do that. So I come here and then I integrate cos x. And remember, when we integrate cos x, we had that it's going to give us what? Sine x. And then I can finally come in and I put my constant k. And that's all. Very simple, right? So see you in the next video where we'll take more questions on integral or integrating trigonometric signs, logarithm signs, and also exponential signs. Okay, so catch you up in the next video.